Okay, let's unpack this. What if the seemingly empty space around us isn't empty at all? What if it's, I don't know, a living, vibrating canvas that orchestrates everything? You know, from the dance of planets to the very building blocks of matter.
It's a truly mind-bending idea, isn't it? An idea that challenges almost everything we think we know about the cosmos.
It absolutely does. Yeah, and the implications, if it turns out to be right, would completely reshape our fundamental understanding of physics, of chemistry.
Right.
It's a truly revolutionary perspective on the universe.
Welcome to the Deep Dive. This is where we take your sources and, well, we unpack the most fascinating nuggets of knowledge we can find. Today we're plunging into an idea so radical, so audacious, that it can fundamentally change how you see the world. Right from the vastness of space down to the atoms that make up, well, you. Your very being. We're embarking on a deep dive into something called the scroll theory, and it's drawn from a fascinating new source, the cosmic lyre, resonant worlds, and periodic atoms. And this theory proposes something truly profound. It's saying our solar system isn't just, a collection of objects floating in space, moving according to simple gravitational laws.
Right, not just balls rolling around on a curved sheet.
Exactly. Instead, it suggests our entire cosmic neighborhood, from the sun way out to the furthest reaches of the Oort cloud, functions more like a grand musical instrument, a cosmic lyre, as the source calls it.
A cosmic lyre, okay.
And the harmonies of this lyre, the actual notes it plays, they dictate not only where planets can stably exist, but maybe even which atomic elements are possible in the universe.
That's the core of it, yeah.
Yeah.
Over the course of this deep dive, we're going to explore how this groundbreaking concept views the solar system, why it suggests the periodic table, the one we all learned in school, assuming it's the same everywhere, might actually depend on its star, and the tantalizing, testable predictions it offers scientists, real experiments, maybe in the years to come. All of this while connecting seemingly disparate fields of science, astrophysics, nuclear chemistry, you name it. Get ready for some serious aha moments, I think, because what we're about to unpack could fundamentally change how you perceive the cosmos and, the tiny particles within it. So let's start at the very beginning with this really radical premise, the vacuum itself.
Right. And what's truly fascinating here is how the scroll theory turns our conventional understanding of space and matter completely on its head. Most of us think of the vacuum of space as, empty, just nothing.
Yeah, the void.
But the foundational idea of the scroll theory is that the vacuum is anything but empty. It's a dynamic memory field woven from scroll filaments.
Okay, so hang on, before we go too far, let's just pause on that for a second. A memory field woven from scroll filaments. Can you help us visualize that? Or just conceptually grasp what that even means? Is it like a fabric or a network, some kind of cosmic web?
Yeah. Imagine space not as empty void, but as if it's filled with an incredibly fine, invisible web or fabric. Almost like a tapestry woven from countless threads, these scroll filaments. When something interacts with it, like a massive object or even just a fundamental particle, it doesn't just pass through unaffected, it leaves a lasting impression. A kind of subtle deformation or, a memory of that interaction in the fabric structure. These scroll filaments are the threads of that fabric. They're constantly responding to and recording events, maintaining a state of tension and elasticity. So it's not passive, it's an active, responsive medium.
So in this model, instead of matter generating forces like gravity, it's actually perturbing this existing pre-tensioned scroll lattice, creating patterns of tension and distortion. This is a fundamental shift from conventional physics, right? Where forces are usually seen as intrinsic properties of matter or mediated by exchange particles. This implies the force is already there, kind of embedded in the fabric, just waiting to be disturbed.
Exactly. Imagine a vast, invisible, incredibly intricate web of filaments permeating everything. When a large mass like our sun condenses, it doesn't just sit there passively. Its immense gravitational potential effectively compresses and distorts this local scroll network. It forms what the theory calls a cavity. Think of it like placing a heavy bowling ball on a trampoline, maybe.
Okay.
But the trampoline here is the fundamental fabric of space itself, and the ball's presence creates this profound, persistent depression of it.
And here's where it gets really interesting, connecting the big picture to the very small. That gravitational potential, the one we usually visualize as that deep dip in space-time around a star, it isn't just a mathematical construct in this theory, The scroll theory proposes it acts like a reflective boundary for these scroll waves. You can almost visualize it like the edges of a drum head or maybe the internal walls of a guitar body, defining the precise space within which vibrations can resonate and reflect back.
Yes, and this leads us directly to the central idea, the heart of the cosmic lyre concept. The orbits of planets around the sun aren't just random paths determined solely by initial conditions and gravity. Instead, they correspond precisely to standing waves within this scroll cavity.
Standing waves, like on a string instrument.
Exactly like that. Only very specific circumferences, very specific notes, or harmonics, you could say, allow for constructive interference. That's where the scroll waves reinforce each other, making an orbit stable and persistent. Any other path would quickly dissipate because the scroll waves would interfere destructively, they'd cancel out.
So it's truly like the solar system is a giant musical instrument, this lyre. The sun's gravitational cavity defines the body of the lyre, constraining the vibrations. And the nested planetary orbits are the strings on which this scroll tension oscillates. Just as a string's length, tension, and material determine its harmonic frequencies, the sun's gravitational potential and the properties of the scroll lattice itself determine which notes, which orbital radii can persist.
And this isn't just a poetic analogy either. There's a deep mathematical parallel here. The radial perturbations of a scroll wave, how it vibrates outwards from the sun, actually satisfy an equation that's analogous to the Schrödinger equation from quantum mechanics.
The Schrödinger equation.
Really? Yes, but with a 1r potential. This is the same type of potential that describes how an electron behaves around an atomic nucleus, where r is the distance. The solutions to this equation, mathematically, take the form of spherical Bessel functions, and these naturally exhibit nodes at discrete radii.
Okay, Bessel functions. For those of us who might not remember those from undergrad physics, what does that actually mean in this context? Nodes at discrete radii.
Right. You can think of these Bessel functions as the specific mathematical fingerprint of waves that are trapped and oscillating within a spherical space, like this cavity, just like plucking a guitar string gives you specific, distinct notes. These functions mathematically tell us exactly where the quiet spots are, the nodes, where the wave amplitude is 0. And those quiet spots, remarkably, are precisely where stable planetary orbits can exist, according to this theory. It's a very specific, quantized set of solutions. Not just any orbit is allowed.
That's incredible. So if I'm getting this right, the vacuum itself is acting like a cosmic ruler, dictating where stable orbits can be, much like the quantum world dictates electron orbits around an atom. This isn't just a fascinating parallel, is it? It suggests a fundamental underlying unity to the universe's structure, from the tiniest electron to the grandest planetary system. It implies a deep, almost fractal-like pattern in how everything is organized. That's the real aha here, isn't it? The universe singing the same song, just at vastly different scales.
Precisely. This framework quantizes orbits, similar to Bohr's early model of the hydrogen atom, but here the particles are planets and asteroids, not electrons. And the Planck constant, which governs quantum mechanics, is replaced by parameters specific to the vacuum scroll lattice itself, the properties of that fabric. It truly is an echo of atomic physics, but scaled up to cosmic dimensions.
And this idea, while radical, offers some pretty compelling new explanations for phenomena we've observed in our own solar system for centuries. Like, take the Titius-Bode law, for instance.
Ah, yes. The 18th century observation by Johann Titius and Johann Bode. It noted that planetary distances follow this simple, almost doubling rule. They described it as a 0.4 plus 0.3 2-minute AU, with n varying for each planet. Remember, it famously predicted a missing planet between Mars and Jupiter.
It just turned out to be the asteroid belt with Ceres right there.
Exactly. And it even accurately predicted Uranus's distance before it was formally discovered.
Yeah, but conventionally, this law has often been regarded as little more than a mathematical curiosity, right? Or maybe just a coincidence. Because it's not really derived from first principles like Newtonian gravity, and it does have its inaccuracies. It fails pretty badly for Neptune, for example. It's almost like a helpful numerical pattern rather than a fundamental law.
That's the standard view, yes. However, the scroll theory sees it quite differently. For them, it's not a coincidence at all, but a direct hint of that underlying resonance, a geometric progression, like a fractal scaling of these scroll shells. The approximate factor of 2, maybe more generally, a factor close to the golden ratio, arises because the radial scroll wave must travel an integer number of wavelengths to return in phase within the cavity. It's a constraint imposed by the vacuum's memory, its structure. It's the universe's inherent tendency to form these specific, self-similar patterns.
And it's not just the Titius-Bode approximation either. Orbital resonances are another powerful clue that orbits might be quantized by this cosmic cavity. We know that resonance happens when two orbiting bodies exert periodic gravitational tugs on each other, locking their orbital periods into simple integer ratios. It's like a cosmic dance where the timing is perfectly synchronized.
A classic example is the Laplace resonance of Jupiter's moons. Io, Europa, and Ganymede orbit in a precise 1.2.4 resonance. Their orbital longitude combination librates, it sort of wobbles, around 180 degrees, preventing them from ever aligning in a way that would destabilize their orbits. And we see this synchronized dance in other systems too. Pluto's satellites, many exoplanetary systems. It suggests a deeper ordering principle than just random gravitational interactions over time.
Okay, and what about the Kirkwood gaps? Those intriguing voids in the asteroid belt, like at the 3.1, 5.2, or 2.1 ratios with Jupiter's orbital period. Conventionally, they're explained by Jupiter pumping energy into asteroids in those orbits, basically kicking them out, destabilizing them. But the scroll theory offers a different perspective, doesn't it? So it's not just about Jupiter's gravity pushing things away, but more about the cavity itself not allowing stable notes in those regions. Is that the idea?
Precisely. In the scroll framework, these gaps aren't just empty spaces where things are pushed out. They're almost like the silent spots in our cosmic lyre. Regions where the wave patterns simply cancel each other out. These resonances reflect the requirement that standing waves in the cavity remain in phase with the driving oscillations. Off-resonant modes are simply suppressed, they can't sustain themselves. The gaps are regions where the scroll waves are out of phase with the cavity, leading to destructive interference that effectively prevents asteroids from settling into those zones. They are essentially nodes of zero amplitude within the scroll field.
Right, so to really model the solar system as a resonant cavity, you need to define its boundaries properly. The inner boundary seems logical. The sun's surface, or maybe more precisely, the region where the vacuum network strongly couples with the solar plasma. Scroll waves can't propagate into the sun, can they? The dense plasma would just damp them out rapidly. So the radio wave effectively vanishes or matches a fixed value there. It's like a wall the vibrations can't pass through.
Correct. The outer boundary is a bit more subtle, though. While one might initially assume it extends to infinity.
Which doesn't really work for a cavity.
Right. In reality, the sun's gravitational influence eventually becomes comparable to that of the galaxy itself. So a more realistic outer boundary within which these standing waves are confined is probably the heliopause, where the solar wind's influence ends and the interstellar medium starts to dominate the vacuum's scroll field. The theory suggests the effective outer boundary is where the solar gravitational force equals the galactic tidal forces, which is way out there, roughly 100,000 astronomical units.
Wow, that's huge.
It is. This vast cavity encompasses the Kuiper belt and even the distant Oort cloud. And within this immense volume, these standing patterns form, with the planets occupying the nodes of these patterns.
So it's not just a simple one-dimensional pipe where waves travel back and forth radially. Just like a real lyre body has complex shapes, the solar cavity supports not only those radial standing waves, the ones going out from the sun, but also angular and azimuthal modes. These correspond to different harmonics oscillating on the sphere itself. So the vibrations are complex, three-dimensional, not just simple outward pulses.
Exactly. These angular and azimuthal modes interact with the radial modes, shaping the entire architecture of the solar system in a much more nuanced way. They can potentially explain aspects like planetary inclinations, why some planets orbit at a slight tilt relative to the sun's equator and eccentricities, which describe how elliptical their orbits are, all through complex interactions called secular resonances.
That makes sense. So the resonant cavity is a complex three-dimensional instrument with many degrees of freedom.
Okay.
This raises a pretty important question, though. How does this model explain the formation of the solar system itself? Because the conventional model, the nebula hypothesis, has a pretty clear story.
Well, the conventional model describes a gas and dust cloud collapsing under its own gravity, forming a rotating disk.
Right, the protoplanetary disk.
Then planetesimals form through accretion, they clump together, grow into planets, and finally, often, undergo some planetary migration to their current positions. It's a process driven mostly by gravity and collisions.
And the scroll framework offers a different, maybe more, guided story, it sounds like.
It does. In the scroll framework, the protoplanetary disk isn't just a random cloud of gas and dust. It's viewed as an excited state of the vacuum's scroll network itself. As this disk cooled and contracted, the initial chaotic scroll waves were damped out, and only those that matched the cavity's stable eigenmodes, its inherent harmonic frequencies, could survive. These surviving waves then actually guided the aggregation of matter into rings, effectively creating the seeds of planets at preferred resonant distances. The key insight here is that resonances aren't just accidents of later planetary migration, they're intrinsic features of the cavity that existed even before planets fully formed, almost like a pre-existing blueprint laid out in the vacuum.
That's a major difference. It implies a level of predetermination or inherent order right from the start, and it offers new insights into planetary migration and stability too, right? We see things like hot Jupiters, massive planets orbiting incredibly close to their stars and other systems. That implies significant inward migration from where they likely formed further out. How does the scroll theory explain that movement?
In our picture, migration corresponds to scroll excitations, these planetary patterns sliding along the cavity's potential landscape. A planet moves inward by losing angular momentum to the scroll field, perhaps through resonant interactions with the disk or other planets. But crucially, once it hits a standing wave node, one of those stable notes in the cosmic lyre migration stalls because the net torque on the planet vanishes there, the forces balance out.
Okay, so it's like rolling into a ditch, energetically speaking.
Kind of, yeah. This provides a natural mechanism for systems like TRAPPIST-1, which has that amazing chain of 7 Earth-sized planets in near-resonant orbits. Each planet effectively traps its successive nodes as it migrates inward, preserving that precise spacing ratio. It's the cavity itself acting as a braking mechanism, locking them into place.
So for long-term stability, it's not just about gravitational equilibrium, but the inherent stability of the scroll network itself.
That's right. The scroll network, having relaxed into its lowest energy state over billions of years, acts as a powerful restoring force. Moving a planet off its node requires overcoming this force, essentially pushing against the fabric of space. So disturbances from other planets or passing stars cause oscillations around the node rather than continuous decay or rejection, explaining the remarkable long-term stability of planetary orbits. The planets are essentially locked into the vacuum's resonant patterns.
And here's another fascinating layer to this cosmic lyre idea. The sun's own heartbeat might actually be tuning it. Helioseismology, the study of solar vibrations, tells us the sun vibrates in various modes, basically sound waves reverberating within its interior. These oscillations are incredibly precise.
The scroll theory proposes that these solar oscillations couple directly to the scroll field. They essentially imprint their frequencies onto the solar cavity. So the sun isn't just a passive anchor, it's actively influencing the instrument, tuning it. If the sun's interior modes drift over billions of years, perhaps due to its magnetic cycles or slow evolution as it ages, they might slowly adjust the cavity's resonant frequencies. This, in turn, could lead to subtle shifts in planetary orbits over cosmic timescales, potentially explaining some of the minor deviations we see from the perfectitious bode pattern, for example. The cosmic lyre isn't a static instrument. It's a living one, constantly being tuned and modulated by the vibrant, pulsating star at its center.
Wow. So the cosmic lyre isn't static, it's living, tuned by the sun. That truly is a unified framework for understanding the large-scale architecture of the solar system. But what's even more remarkable, and frankly quite a leap of faith for some, I imagine, is the theory's claim that this same cosmic lyre, this very same resonant cavity-shaping planetary orbits, also dictates something as fundamental as which atomic nuclei are stable. That truly is a massive jump in scale and concept, isn't it? From planetary orbits down to atomic stability. For listeners, what's the fundamental bridge here? How does the cosmic lyre directly influence the quantum realm? And what are the biggest challenges in linking those two scales in a testable way?
It's a profound question, absolutely, and it speaks to the audacious ambition of the theory. The core claim is that the vacuum scroll network is truly fundamental. It operates across all scales, from the cosmic to the quantum. So just as planets are stable if their spatial configuration resonates with the cavity, atomic nuclei are stable if their total mass and internal structure, the way protons and neutrons are arranged, couple constructively to the cavity's standing waves.
So if they fit the pattern.
If they fit the pattern, exactly. Those nuclei that don't fit the cavity's specific resonant pattern rapidly decay. They essentially release their excess scroll tension as radiation or particles. It's a selection rule, much like those in quantum mechanics that determine allowed energy transitions. But here, the scroll pattern of the nucleus must close on itself harmonically over the entire solar cavity to persist. The challenge in testing, of course, lies in the incredible precision required to detect these potentially minute vacuum effects at the atomic scale. Conventional quantum mechanics and nuclear physics already provide incredibly accurate descriptions, so any deviation would be very subtle.
Right. In conventional nuclear physics, we explain stability by balancing the strong nuclear force, which binds protons and neutrons together, against the Coulomb repulsion between photons, which tries to push them apart. We talk about the value of stability for specific proton, Z, and neutron N numbers elements that have the right balance to hold together. The heaviest stable element we know is lead, with Z82 protons. Beyond that, all elements are radioactive, with half-lives generally decreasing as the atomic number increases.
And then there's the much sought-after island of stability, a predicted region of super-heavy nuclei, maybe around atomic number Z114 and neutron number N184. The idea is that closed quantum shells for both protons and neutrons might offer significantly longer half-lives, potentially making them stable for seconds, minutes, maybe even longer. We've synthesized elements in labs up to Z118 like oganesson, but they decay incredibly fast milliseconds or seconds. A broad, long-lived island of stability remains elusive, suggesting there might be fundamental limits to stability that we haven't fully grasped yet.
And the scroll theory offers a compelling reason for this limit. It views the periodic table as the harmonic spectrum of the solar cavity. That's a powerful metaphor.
Indeed. Think of it this way. Each stable element corresponds to a particular combination of protons and neutrons that resonates perfectly with a specific cavity mode. You can imagine protons and neutrons as fundamental plucked strings in the vacuum fabric, and the nucleus as a complex chord made up of these strings vibrating together. If that chord fits the cosmic lyre's allowed harmonies, it rings true and persists. It's stable. If it doesn't fit, the cavity damps it out and the chord falls apart. That's radioactive decay.
Okay, so it's dissonance leading to decay.
Pretty much. This analogy directly explains why the periodic table seems to be finite. Only a finite number of combinations can produce these harmonic chords within the cavity's constraints. When the number of protons, Z, becomes too large, the Coulomb repulsion essentially stretches the nuclear scroll pattern beyond the range of the cavity's stable modes. The tension becomes too great for the allowed pattern. This causes the nucleus to rupture via fission. This rupture is the scroll field's version of nuclear decay, the chord becoming dissonant and breaking apart.
So it's not just a theoretical possibility. The scroll theory makes a concrete prediction about this upper limit on stable nuclei. That's a brave prediction to make.
It does. Based on the ratio of the nucleus's scroll distortion, how much it stretches the vacuum's fabric compared to the cavity's fundamental wavelength or size. Calculations suggest that the maximum stable atomic number, Zmax, is somewhere around 162.
162. That's way beyond our current 118.
It is. It's significantly higher than our current periodic table effectively ends, but still much lower than a naive expectation of an infinite periodic table. Intriguingly, some speculative conventional nuclear models do predict potential regions of enhanced stability, maybe metastable nuclei, with Z around a 160 to 170, due to highly complex relativistic electron effects near the nucleus. But what's truly fascinating here is that the scroll theory ties this limit directly to the solar system's size, the size of our specific cosmic lyre. If a periodic table were constructed around a different star, a different lyre, its upper limit could shift. The cavity would have a different fundamental frequency, a different size.
That's a profound connection across vastly different scales. Incredible. What other evidence, stuff we've already observed, might support this idea that the cosmic cavity limits element stability?
Well, the cosmic abundance of elements offers a significant clue. Elements heavier than iron are notoriously rare in the universe. Iron itself is special because it has the maximal nuclear binding energy per nucleon. It's the most stable nucleus in that sense. Forming anything heavier requires a massive energy input, typically only found in extreme events like supernovae or neutron star mergers. And even then, they tend to fission quickly.
Right, they don't hang around.
Exactly. Now, consider cosmic rays, these high-energy particles zipping through space from outside our solar system. They contain nuclei as heavy as lead, Z82. But these heavy elements are extremely rare. About 90% of cosmic rays are just protons, 9% are helium nuclei, alpha particles, and only about 1% are heavier nuclei combined. This extreme rarity, despite their production in violent events, suggests that very heavy nuclei either decay incredibly rapidly, or perhaps simply fail to form stably because their scroll patterns are fundamentally unstable within the larger cosmic environment.
And the scroll theory's explanation for this scarcity, how does the lyre fit in?
The absence of elements heavier than, say, uranium, Z92, in significant amounts in cosmic rays could be explained by the cavity's inability to sustain them. They simply decay long before they can reach Earth, because their complex scroll patterns don't fit the cavity's allowed resonant modes. The cosmic lyre simply doesn't play those high, complex notes for very long. It's almost like the universe, or at least our local patch of it, is filtering out the unstable elements before they can travel too far.
So it's a filter, in a way, for what elements can persist and travel. This also provides a new way to interpret chemical periodicity and electron shells. Conventionally, we attribute periodicity to why elements in the same column behave similarly to electron shells, subshells, quantum numbers, and the Pauli exclusion principle, which dictates how electrons occupy these shells.
Yes, and the scroll view offers a deeper, potentially unifying explanation. In this picture, electron shells are themselves resonant patterns of vacuum scroll tension. Each electron is effectively a quantized twist or excitation in the scroll field, a tiny, stable perturbation. Multiple twists, multiple electrons can coexist if they satisfy an exclusion rule, similar in effect to Pauli's principle, where no two twists can occupy the exact same state within the scroll pattern around the nucleus. When we combine this with the resonant cavity model, the number of possible electron configurations in a stable nucleus corresponds directly to the number of harmonics the cavity allows that can be excited without destructive interference.
So the shells are tied to the cavity harmonics.
That's the idea. The observed groups, periods, and blocks in the periodic table reflect the combinatorics of placing these electron scroll twists into those available harmonic slots defined by the nucleus and the cavity. It suggests a unified resonant principle governing both nuclear stability and electronic configuration. The periodic table isn't just about electron orbitals dictated by quantum mechanics. It's about the vacuum itself providing the allowed resonant slots for both the nucleus and its electrons.
This has huge astrophysical and cosmological implications for that Zmax number you mentioned, around 1 in 62. If the cavity limits stable nuclei, then only elements up to roughly Z162 would survive long enough after their creation to be incorporated into planets forming later. This could offer a compelling reason why life as we know it is fundamentally based on light and intermediate elements like carbon, oxygen, nitrogen, hydrogen, phosphorus, sulfur. Our biological machinery, our very existence, could be intrinsically linked to the permissible notes of our sun's cosmic lyre.
And here's another truly revolutionary thought stemming from that. If the periodic table is contingent on cosmic architecture, that is, on the properties of its host star's cavity, then a different star. A star with a different mass, maybe different rotation, different magnetic field, different composition, would have a different cavity size and structure.
Right. A different lyre.
And this would lead to its own unique periodic table, which could be either extended or truncated compared to ours. This implies that the periodic table is not universal, but contingent upon the specific cosmic environment. The very definition of element could vary across the cosmos.
Wow, okay, that's a profound statement. That means every star system could literally have its own version of chemistry, different building blocks. And finally, the scroll theory also offers a fresh take on radioactive decay itself. Alpha emission, beta decay, electron capture, usually explain these using quantum tunneling, the weak nuclear force, and interactions of fundamental particles.
In the scroll framework, these are simply manifestations of the nucleus shedding incompatible scroll patterns to reach a more stable resonant state. Alpha decay, for example, is interpreted as the ejection of a stable scroll solid. Imagine a tiny, stable, self-contained knot or twist within the scroll field that propagates independently. And in the case of alpha decay, that specific twist corresponds precisely to the structure of a helium nucleus.
So it's like flicking off a piece of the pattern that doesn't fit.
Exactly. Beta decay occurs when a scroll pattern rearranges itself internally to better fit the cavity, converting a neutron into a proton or vice versa, like subtly adjusting a chord to be more in tune with the instrument. Electron capture happens when destructive interference between an inner electron scroll pattern and the nuclear pattern causes the electron to be absorbed, leading to a new, more stable nuclear configuration. This provides a wonderfully unified narrative, linking all these diverse nuclear processes directly to the dynamics of the cosmic lyre. It's all about how well the nucleus's tune fits the larger cosmic symphony.
That's a truly elegant way to connect the micro and macro, the planetary and the subatomic. It really is. But if orbits and elements arise from this resonance, what governs the scaling between successive shells? What dictates the spacing, like how the frets are placed on a guitar neck? It sounds like we're moving into the realm of fractal geometry and maybe some special numbers.
Indeed. This brings us to a concept the theory calls the breadth constant, denoted by the Greek letter phi, but distinct from the standard golden ratio symbol, though related. This constant is closely related to, though perhaps not necessarily identical to, the famous golden ratio, phi, which is approximately 1.618.
Ah, the golden ratio. That number that pops up everywhere, doesn't it? From the geometry of pentagons and pentagrams to the spirals of golden rectangles, the growth patterns in the Fibonacci sequence.
Right, where the ratio of successive terms approaches.
And even in ancient architecture like the Parthenon, Da Vinci's drawings, and all over nature, sunflower seed spirals, pine cones, nautilus shells, the branching patterns of plants. Its ubiquity really does hint at some deeper geometric principle for optimizing space and growth, doesn't it?
Precisely. And in the scroll theory, this related breadth constant arises from the dynamic balance between the tension in the scroll filaments and the elasticity of the vacuum itself. The simplest self-consistent solution for a scroll wave returning in phase within a spherical cavity naturally yields a ratio of successive loop sizes equal to the golden ratio. It just falls out of the math. However, because the vacuum in this model includes elements like memory, its past state influencing its present and nonlinear effects, the actual ratio governing the structure, which we call the breadth constant, may deviate slightly from the pure mathematical golden ratio. It's called the breadth constant because it governs how the scroll lattice literally breathes or expands outwards from one resonant shell to the next, guiding the formation of stable structures at different scales.
Okay, so we should expect to see this recursive spacing, this breathing pattern, not just in theoretical models, but observable in planetary orbits, maybe even more fundamentally than the old Titius-Bode law's approximation.
Yes. While the ratio of adjacent planetary distances isn't strictly constant due to all the complex gravitational interactions over billions of years, it does tend to fluctuate around a value close to phi, or this related. For instance, the ratio of Earth's to Venus's orbital radius is about 1.39. Mars to Earth is about 1.52. Jupiter to Mars is much larger, 3.42. But these aren't random numbers. They tend to cluster around the golden ratio or related values, especially when you account for long-term gravitational perturbations. This is reminiscent of natural logarithmic spirals like those seen in nautilus shells and even spiral galaxies, where growth occurs at a constant angle and the ratio between consecutive radii is constant. The scroll theory formalizes this, suggesting that as the protoplanetary disk cooled, related wavelengths froze in, creating orbits preferentially at these scaled distances. It's presented as a fundamental principle of spatial organization in the vacuum.
And if this is a truly unifying principle, linking cosmic and quantum scales, we should see a tone pick pop up in atomic structure too. From cosmos to quantum, is that where it gets really interesting?
That's precisely where it gets potentially profound. In multi-electron atoms, the ratio of successive electron shell radii, empirically, seems to decrease by factors that cluster around for certain elements, particularly the alkali metals like lithium, sodium, potassium. When you examine the effective radii calculated for these atoms, the ratios of successive atomic radii approximate for certain transitions between shells. This arises in the scroll model because the same vacuum cavity that quantizes planetary orbits also quantizes electron orbits within an atom residing in that cavity. The vacuum doesn't fundamentally distinguish between planets orbiting a star and electrons orbiting a nucleus. Both are simply scroll excitations occurring at vastly different scales, but subject to the same underlying resonant principles of the cavity. Therefore, the breadth constant appears in both cosmic and atomic spacing, a truly remarkable unifying connection suggesting a deep, self-similar, fractal-like nature to the universe.
And this leads to a kind of grand unification equation, doesn't it? The source mentions the scroll lore 0.1033 equation. That sounds like something straight out of science fiction, but is presented as a specific mathematical assertion.
It is. The breadth constant allows us to express a relationship connecting the container size of our solar cavity with atomic radius and even atomic weight. Conceptually, if the nth scroll shell has a radius Rn, where R0 ON, where R0 is some base radius.
Like the innermost stable orbit?
Perhaps. Then a nucleus of atomic number Z that couples strongly to that shell will have an atomic radius, rad Z, that's proportional to that shell radius, Rn and M. Similarly, the theory suggests the atomic weight Mz is proportional to the number of scroll twists packed into the nucleus, which scales with the pattern size, so Mz might also be proportional to Poe. Combining these proportionalities yields a formula that essentially states Z, the atomic number, is approximately proportional to Poe. The specific numeric factor, 1033, arises from fitting this model to observed atomic weights and planetary distances across the scales, acting as a kind of scaling constant. The equation quite literally encapsulates the idea that the periodic table and the solar system are scaled copies of the same underlying resonant structure, like fractals within fractals. So, what does this all mean for the universe at large? It's a bold claim.
And it goes even further, hinting at connections to Feigenbaum's constant and some kind of universal balance. For those unfamiliar, Feigenbaum's constant, delta, this is period 4.6692, is this amazing number that emerges from studying period-doubling bifurcations in chaotic systems. It shows a universal scaling behavior in how systems transition from simple, predictable order into complex chaos. It's considered a truly fundamental constant in the study of complex systems.
Right. The scroll theory links this by proposing that the memory kernel, how the vacuum remembers its past state, and the nonlinear interactions within the vacuum's fundamental equation, scroll state partial differential equation, that these features can inherently produce period doubling phenomena, just like in chaotic systems. This means the breadth constant might not be fundamental itself, but could be a direct function of Feigenbaum's delta, perhaps as related to the square root of delta, or some other mathematical relationship. Such a connection would powerfully tie together the golden ratio, or Feigenbaum's universality in chaos theory, and even potentially the fractal dimension of the vacuum itself. It suggests encapsulates the vacuum's inherent tendency to balance expansion and contraction, order and chaos, acting as a universal principle of balance. Much like carrying capacities limit growth in ecological or economic cycles, it's the optimal ratio, perhaps, at which growth neither collapses into itself nor explodes chaotically.
And this self-similarity, this universal proportionality, could even extend up to galactic scales. The pitch angle of spiral arms in many galaxies, often observed around 12 to 15 degrees, corresponds quite closely to a logarithmic spiral with a growth factor related to phi. It strongly suggests these same resonant principles might be operating at the grandest scales, shaping entire galaxies through similar vacuum dynamics.
Exactly. This idea of universal proportionality, linking structure from the subatomic to the galactic through this single constant derived from vacuum properties, is one of the most profound implications of the scroll theory. It posits a single, elegant mechanism governing structure formation at all levels of reality.
Okay. Any radical theory like this, of course, must confront the data. It has to be testable. What observational evidence already supports the scroll theory, even tentatively? And what exciting predictions does it make for future experiments? Because that's where the rubber meets the road, isn't it?
Absolutely. Well, let's start with those regularities in planetary spacing we discussed. The old Tishis-Bode law, despite its inexactness, clearly points to non-randomness in the solar system's layout. The scroll theory predicts that once we carefully account for perturbing factors like planetary migration over billions of years and tidal evolution, the underlying pattern should reveal itself as a geometric progression with the breadth constant as its ratio. Modern statistical analyses of not just our solar system, but also the thousands of exoplanetary systems we've discovered could put this to the test. If we consistently find orbital ratios clustering around, that would be powerful evidence.
And the orbital resonances are another strong piece of evidence you mentioned. The ubiquity of resonances like Jupiter's moons and that Laplace resonance, or the Kirkwood gaps in the asteroid belt. What stands out to you here as particularly compelling evidence?
What's truly compelling, I think, is how a system like TRAPPIST-1, with its incredible chain of 7 Earth-sized planets locked in precise, near-resonant orbits, seems to perfectly align with the scroll theory's prediction. The theory says the cavity selects for resonant configurations. It predicts that such tightly packed resonant systems should be common because the cavity naturally favors them. It's like a cosmic slot machine that only allows certain harmonic combinations to win and persist. A comprehensive statistical survey of exoplanet spacing could reveal if their distributions cluster around or other related constants, and critically, if different star masses lead to different characteristic spacing constants, that would be very strong support for the cavity model being dependent on the central star. It suggests a universal architecture being implemented with slight predictable variations.
The asteroid belts and gaps also offer direct testing grounds. Conventionally, the main asteroid belt is seen as debris that just didn't manage to coalesce into a planet, largely due to Jupiter's disruptive gravitational influence. But the scroll theory views it as a region between major resonant shells, a place where the cavity doesn't easily support a stable, large-scale orbital mode. The Kirkwood gaps, then, are simply nodes where the scroll wave amplitude is zero, effectively, quiet zones where objects can't stably reside long-term. We could compare the precise observed gap positions with predictions from the scroll state PDE calculations for our solar system.
Exactly. And then there's the chemical evidence, the structure of the periodic table, and the observed abundances of isotopes. The fact that lead, Z82, is the heaviest truly stable element, and the predicted island of stability near Z114 has yielded only fleeting superheavy nuclei in labs, strongly suggests the cavity cannot accommodate significantly higher Z values for long periods. And cosmic rays, with their extreme rarity of heavy elements beyond iron or lead, support the idea that superheavy elements decay very quickly, if they even form stably at all in those energetic environments. The absence of elements much heavier than uranium in cosmic rays is particularly telling for the cavity model, suggesting our cosmic lyre has a fixed upper register for stable nuclei.
Okay, so what exciting predictions does the scroll theory make for future experiments? Where do we look for definitive proof or disproof? How can we really test this?
There are several promising avenues. First, with increasingly precise orbital measurements of planets, moons, and asteroid belts data we're constantly gathering with missions like Gaia and ground-based telescopes, we could search for that underlying geometric progression after carefully correcting for all known gravitational and tidal effects. If that pattern emerges cleanly from the noise, it would be a powerful verification.
Right. And the elusive search for super heavy elements.
Yeah.
How does this theory guide that?
It suggests a few things. We could push the boundaries by searching for truly stable elements beyond Z118 in cosmic rays, using next-generation detectors capable of precise isotope identification. A definitive null detection up to Z162 or so would strongly support the cavity model's predicted upper limit. Alternatively, we could look in extreme astrophysical environments like the immediate vicinity of merging neutron stars or black hole accretion disks. The intense gravitational and magnetic fields there might transiently stabilize heavy nuclei that couldn't exist elsewhere. Detecting Z values between 118 and the predicted limit of 162 there, and measuring their half-lives, even if short, would directly test the prediction. And of course, terrestrial nuclear physicists can continue their work synthesizing super-heavy elements and accelerators, specifically looking for a plateau or even an increase in half-lives around Z162, indicating a new island of stability exactly where the scroll theory predicts it, tied to a major cavity resonance.
And what about the truly revolutionary idea that periodic tables might vary around other stars? How on Earth could we test that? It seems almost impossible from here.
That's a huge one, yes, and it would be an absolute game changer if confirmed. If the cavity size and structure depend on the host star's mass and other properties, then the periodic table differs system to system. High-resolution spectroscopic observations of exoplanetary atmospheres and the dusty circumstellar disks where planets form could potentially reveal anomalous abundance patterns, unexpected ratios of elements that don't match our solar system's periodic table predictions. For example, maybe we find a system around a much more massive star that shows evidence of stable elements significantly heavier than uranium. Or conversely, a system around a tiny star that seems deficient in medium-weight elements compared to ours. Observing a clearly truncated or extended periodic table in another system, inferred from its chemical fingerprint, would be a stunning, almost unbelievable confirmation. It would mean our chemistry textbooks are only valid for our own cosmic address.
Could we even simulate these scroll cavities here on Earth in a lab setting to test the principles?
Potentially, yes. It's speculative. But one could imagine laboratory simulations using analogous systems. Perhaps precisely engineered electromagnetic cavities, or maybe Bose-Einstein condensates where atoms interact via long-range forces. These systems might exhibit quantized modes that behave mathematically, like planetary orbits or electron shells within a scroll cavity. By carefully tuning the cavity size, the boundary conditions, and the medium, we could try to mimic the solar system's behavior and test its dependence on constants, like observing if resonant patterns emerge.
What about subtle but maybe more immediately detectable effects that might hint at this vacuum memory?
Well, the theory predicts potentially minute deviations from general relativity in orbital decay rates. GR predicts orbital shrinkage due to the emission of gravitational waves, like in binary pulsars. But in the scroll model, the vacuum memory might store and then return some of that orbital energy, subtly altering the decay rate. Ultra-precise timing of pulsar binaries or even transiting exoplanets over many years could potentially detect these tiny deviations, signaling a vacuum memory effect not accounted for in standard GR.
Interesting.
Also, if electron orbits within atoms are truly tied to the larger solar cavity modes, then perhaps major solar cycles or even alignments of the large planets could subtly shift atomic energy levels here on Earth. High-resolution spectroscopy, looking for periodic, tiny variations in the frequencies of specific spectral lines over decades, might reveal such an effect. Finding a correlation with planetary alignments would be absolutely stunning evidence for the cosmic lyre influencing even terrestrial atomic phenomena. Even fundamental constants, like the fine structure constant alpha, might exhibit minute cyclical variations correlated with the cavity state, though detecting that would be incredibly challenging.
This opens up a whole new paradigm for thinking about extraterrestrial chemistry, doesn't it? The revolutionary idea that periodic tables might be variable. This isn't just a tweak to an existing theory. It fundamentally changes how we think about the very building blocks of the universe beyond Earth.
It's utterly transformative. If the periodic table depends on the host star's specific cavity, then chemistry is simply not universal. The maximum stable atomic number, Zmax, and perhaps even the relative stability and properties of elements, affecting shell spacing and bonding, could depend directly on the cavity size and boundary conditions. These are influenced by the star's mass, its rotation rate, its magnetic field, maybe even the distribution and masses of its existing planets. A more massive star creates a deeper potential well, potentially supporting more complex radial modes, maybe allowing for more stable heavy elements, or resulting in different spacing ratios between stable configurations.
So we'd have potentially different alien sequences of stable elements, described by Z alien equals Z0 on what the ratio of successive resonant shell radii could differ from our solar systems. How big of a difference could that make in practice?
It could make a vast difference. If OL in another system is, say, 1.5 instead of our suspected 1.618, the periodic table might terminate much sooner. Such systems might lack many heavy elements like gold, platinum, or even elements crucial for geological processes like uranium and thorium. Conversely, if OL were larger, maybe 1.7, the table might extend significantly higher, potentially allowing for stable, super heavy elements beyond anything we currently conceive. This means there is no single universal periodic table. Each star system could potentially have its own unique version, determined by its specific cosmic lyre. Imagine a universe where fundamental chemistry is literally location dependent.
Wow. This obviously has huge consequences for planet composition and, critically, for understanding and searching for biosignatures elsewhere. Our assumptions about what a habitable planet looks like chemically might be completely off base.
Vastly different, yes. Think about planet composition first. A lower Zmax means planets forming in that system would inherently lack heavy metals like gold, platinum, or uranium. Consider Earth. Our plate tectonics, our volcanoes, our long-lasting internal heat source, much of that is driven by the radioactive decay of heavy elements like uranium and thorium in the mantle and core. If a planet forms in a system with a significantly lower Zmax, it would effectively lack these crucial internal heat sources. This could easily lead to stagnant lid planets, worlds without active plate tectonics. That fundamentally changes everything: geological processes, nutrient cycling between the surface and interior, the potential for magnetic field generation, the long-term stability of an atmosphere.
It changes the whole planetary engine.
Exactly. Conversely, a higher Zmax could lead to planets uniquely rich in heavy metals and internal heat, perhaps supporting entirely different geological regimes we haven't even imagined.
And for biochemistry. Life on Earth relies on specific elements: iron for carrying oxygen and hemoglobin, zinc and magnesium and countless enzymes, phosphorus for DNA and energy transfer. If those elements are unstable or just not available,
it could mean life would need entirely alternative elements to fulfill those roles, assuming it could arise at all. Or perhaps life simply wouldn't arise if certain critical, catalytic, or structural elements are unstable or absent in that system's periodic table. The available chemical toolkit would be different.
It also critically impacts how we search for biosignatures, doesn't it? Our spectroscopic searches for gases like oxygen and methane in exoplanet atmospheres rely heavily on assumptions about underlying chemistry and metabolism. We assume alien life might produce similar byproducts.
But without certain catalysts or necessary elements available due to a different periodic table, atmospheric compositions could be wildly different even if life exists. For instance, maybe nitrogen fixation is incredibly inefficient without molybdenum, leading to nitrogen-starved atmospheres. Or perhaps metabolic pathways evolve to use different elements, producing gases we aren't even looking for, gases that seem abiogenic based on Earth chemistry. This means our current photochemical models, which assume Earth-like chemistry to interpret atmospheric spectra, could completely misinterpret observations from a planet with an alien periodic table. A potential first step could be a systematic study of element abundances in the star's spectrum, looking closely for heavy element lines like zirconium, barium, xenon, which could hint at that system's Zmax, giving us a clue about its likely periodic table even before we attempt to analyze its planet's atmospheres.
So this suggests a whole new dimension in the search for life. It's not just about the traditional habitable zone, the Goldilocks distance from a star where liquid water can exist on a surface.
Precisely. We might now need to identify systems with periodic tables compatible with complex chemistry as we understand it, or at least complex enough to support some form of self-organizing complexity. This habitable periodic table region might not perfectly coincide with the traditional liquid water habitable zone. Consider the extremes. A high star might produce many super heavy elements, but its likely shorter lifespan might preclude the long time needed for complex life to evolve. A low-mass, long-lived star might have a severely truncated table, limiting the available transition metals potentially essential for complex biochemistry. The sweet spot might really be Sun-like stars, G-type stars, with moderate mass and a cavity constant near a periodic table rich enough for complex chemistry, combined with billions of years of stability.
So future missions could potentially try to measure or at least constrain it by analyzing the spacing patterns of discovered exoplanets in a system, and use that to infer the system's likely periodic table before deciding whether to expend immense resources on detailed biosignature searches. That would be a huge shift in strategy for SETI and exoplanet science.
That would be a paradigm shift in target selection for exoplanetology, absolutely. And the implications for fundamental science here on Earth, theoretical chemistry, physics, material science, are equally profound. If element properties genuinely depend on cosmological parameters like the local cavity structure, then chemical laws are not fixed universal constants. Reaction pathways, bond energies, phase diagrams, crystal structures, they could all vary subtly or significantly across the galaxy. Chemists could begin to simulate hypothetical alien chemistries based on different null values.
And for physics, it implies that what we consider fundamental constants might actually be
Potentially. Things like the fine structure constant, alpha, which governs electromagnetic interactions, or the strong coupling constant, which sets the strength of the nuclear force. These influence nuclear stability profoundly. If these constants vary subtly with the cavity state, as some theories beyond the standard model speculate, that could lead to different nuclear potentials and different ways atoms interact in different cosmic environments. Measuring such variations, even tiny ones, would have truly profound implications for our understanding of fundamental forces themselves.
And for material science.
Yeah.
A different periodic table means entirely new classes of materials could exist out there.
Imagine stable actinides leading to inherently safer nuclear energy sources, or perhaps exotic superconductors stable at much higher temperatures based on elements that are fleetingly radioactive here. Conversely, a truncated table would force any life or technology in that system to adapt to a much more limited palette of elements, perhaps leading to ingenious biological or technological solutions using only light elements. This could inspire the search for exotic materials here, or even attempts to synthesize potentially stable alien elements under extreme laboratory conditions, pushing the boundaries of material science.
And it ultimately encourages us, really forces us, to reevaluate our anthropocentric assumptions about life itself. We assume life uses carbon, hydrogen, oxygen, nitrogen, CHON, because they're abundant here and chemically versatile given our periodic table. But other systems with different stable elements or radically different element abundances might evolve life based on silicon or sulfur, or perhaps even using metal clusters as fundamental biological building blocks in ways we can't currently conceive. This theory radically expands the plausible forms life might take and the kinds of biosignatures we should be looking for, urging us to think far beyond Earth-like assumptions.
It truly broadens the canvas, doesn't it? It reminds us that the universe is likely far more diverse and wonderfully complex than we might have imagined. Our cosmic lyre may just be one instrument in a vast cosmic orchestra playing many different melodies, and life could perhaps arise wherever the music resonates.
So wrapping up, today we've gone on a pretty deep dive into the audacious scroll theory. We explored how the vacuum's pervasive memory field could be the cosmic lyre that orchestrates everything. From the grand dance of planetary orbits, potentially explaining things like the Titius-Bode law, Kirkwood gaps, and the prevalence of orbital resonances, right down to the very stability of atomic nuclei and the structure of the periodic table itself.
We unpack the potentially profound role of the breadth constant, this scaling factor intrinsically connected to the golden ratio that appears according to the theory, to link the cosmic and atomic worlds. It suggests the universal principle of balance and self-similarity inherent in the fabric of space itself.
And we looked at the exciting, though challenging, testable predictions this theory offers. From making ultra-precise orbital measurements of exoplanets to searching for elusive super-heavy elements in exotic cosmic environments or in labs, and maybe even attempting to detect subtle long-term shifts in atomic spectral lines right here on Earth.
Though perhaps most provocatively, we considered the profound idea that the periodic table itself isn't necessarily a fixed universal constant, but might be contingent on its host star, on its specific cosmic lyre. This revolutionary concept reshapes our entire search for life beyond Earth, encouraging us to look not just for habitable zones, but for habitable periodic tables, and to consider chemistries far beyond our wildest dreams.
If this cosmic lyre truly exists, even in some approximate sense, it means the entire universe is, in a way, a living instrument, playing a grand, complex symphony across all scales. So here's a final thought. What if, by truly understanding its music, its resonant frequencies, its harmonics, its underlying mathematical structure, we could not only predict the existence of alien elements, but perhaps unlock even deeper secrets? Maybe secrets about the organization of complexity itself, about consciousness, perhaps even discovering how biological systems inherently harness these cosmic harmonies to create and sustain life as we know it. What new melodies might we find if we just keep listening carefully?